friend who teaches at another school who never does any labs with her students. She probably had a better passing average than I had over the last 2 years, maybe equal to it anyway. She never touches a lab. It's a bit of a lie that they act like the AP folks act like you're supposed to do one every week, hours and hours. Like that's impossible to do, number one. Number two, I know people who don't do any lab and their students make just as good grades. So, but I think you should do some. It's just not as important as some people think it is. Okay, here we go. Atomic radius. So these are the kind of questions that are the most difficult to answer correctly. Okay. Let's see if we can get there's an answer key, right? Yes. Keep me from having to rewrite something I've already written. We can just toggle back and forth here. So these are the type questions. They're almost not questions. They're more like true statements that you're trying to explain, right? So a big thing on an AP free response is to make sure we understand the difference in an explanation and an observation. Okay. So this is what we want. Okay. Now we, not me, the AP folks want an explanation. They do not care about your observations, no matter how factual they may be. They will not give you credit for it, okay? So on an AP exam, there are no points taken off for anything, okay? There are only points earned. That makes sense? Like when I grade a test, normally like in regular chemistry, I'm grading their test on Friday. Everybody has 100 when you turn it in. And I do minus this, minus that, minus whatever, right? And then I subtract all those from 100, and that's your grade, right? On AP exam, everybody starts with 0, okay? And you build yourself up from there, all right? So observations, factual statements, no matter how true they may be, are not awarded points if they're not the explanation for why something is. That makes sense? So I've had people say, well, how can they mark off for the right, for true statements, but they're not marking anything off? They're just not awarding you the points for what you were asked to put down. And there's a difference there. There's also a different mindset to taking a test that's graded that way. You're trying to climb a ladder, okay? On any AP test, everybody at 8 o'clock that morning, or y'all's test at noon, whatever time, let's say it's at noon. At noon, all 150,000 students in America have a 0, okay? And at noon, they say go, and everybody's trying to climb a ladder. The highest 10 or 15% of people up here at the top who get the highest on the ladder are going to get a 5, no matter whether they got as high as the people last year, the next year, whatever, okay? Everybody's climbing the ladder. And as the race goes on for that 4 hours, all 150,000 people are going to get distributed on this ladder, okay? And the people at the top get a 5, and the next people get a 4, and these people get a 3, and these people get a 2, and the most of the people are down at the bottom still, and they get a 1, right? And that's essentially how it's graded. So what you're doing is you're scrambling around looking for points, okay? So it's a scavenger hunt for points. The object is not to get to the top of the ladder and get all the points. That's not going to do you any good, because the person at the very top of the ladder and the person about 10 rows down still both get a 5. Okay, so trying to be the number one top person at the top, like you might in here, like you're trying to make 100 on a class test, will be detrimental to your score on the AP exam and the ACT, by the way. Okay, unless you're trying to make a 36 on the ACT. Okay, which is obviously possible, right? There is no reward for scoring higher than 75% on AP exam. The person that scores 75%, the person that scores 99%, make the same score. There's a 24% difference in that, but they get the same 5. Okay, and you're never going to know that you made 75 or 99. You'll never know that. I won't know it. You won't know it. Nobody will know it.
You get like a 100%, they'll tell the school.
I don't think so. Not that I'm aware of.
Well,
And only like 3 people do that every year. So.
Well, on like the college board Twitter, whenever they were like releasing scores, they were saying that like 4 out of the 400,000 people that took a certain exam got.
Right,
like,
but I don't know that those people are ever notified.
I don't know about the people that said that like their schools have been notified.
They might be. But at the end of the day, it doesn't matter. Okay, so that's a totally different test-taking strategy. Okay, totally different test-taking strategy. We'll talk about that off and on a good bit as we approach that test. Okay, so here's the questions. First off, they start with factual statements. So we're not arguing the factuality of these statements. Okay, these are not true-false questions. Everybody understand that? Because every year I get people who are like, no, because of this. Well, no, this is not a yes, no, true, false. Okay, these are factual statements. Lithium is smaller than potassium. That's fact. Boron is larger than fluorine. That's fact. Fluorine is smaller than iodine. Cesium is larger than sodium. And krypton is smaller than potassium. Those are all facts. We're looking for the atomic structure reason why. Okay? Everybody write that down. The atomic structure reason why. Okay? No other reason why is acceptable. Only the atomic structure reason is acceptable. Anything else is an observation, no matter how true it may be. It's an observation. The only acceptable chemical explanation for anything is structurally based. In these cases, it's atomic structure. Later on, we'll have questions that we'll be looking at molecular structure. Not there yet. Right now, it's just atomic structure. The other thing that they want to see is you mentioned the atomic structure of both substances in the statement. Okay? I hope I did that in my answer. Sometimes I get lazy and don't do that, but that's expected and therefore required. Okay? Let's see how I did. Yeah. Not great. I should have done a little more in depth.
Mr. Cagle would have got 3.
Yeah, probably 3. Okay. All right. So the why for the first one. Lithium has a smaller radius than potassium because potassium's valence electrons are at a higher energy level. Now I need to be more specific. Okay. This old answers. Who knows how long ago I typed this? 10 years ago or more probably. All right. Need to be more specific. Okay. Specifically, which energy level is lithium's valence electron?
2s.
It's in the second energy level. You can say 2s. That's fine. How about potassium's?
4.
The 4th. Okay. So you need to be more specific, right? Everybody follow that? Do you have a question?
Oh no, I thought we were gonna call it and say like who's got the answer. So
No, we put the answer right there. Okay. All right, boron is larger than fluorine. Why? Okay. All right. Yeah, these are old answers because this is missing a very key bit of information. So we want to add some stuff here. So boron is larger because it has fewer protons than fluorine, and therefore boron has a larger atomic radius. We need to put this in there. Okay, this must be really old. I must type this a long time ago. Okay. We need to put this in here, all right, that fluorine has a greater effective nuclear charge. Greater effective nuclear charge.
I have that on my paper, and like I know that boron is larger because it has greater effective nuclear charge, but what exactly is greater effective nuclear charge?
It has more protons that are having a greater effect on holding the electrons. So what do protons do? What is their purpose in being created by God some number of years ago? Somewhere between who knows when and 14.2 billion. Best anybody can guess. What's the purpose in a proton?
To hold things.
To hold what things?
To hold the electrons.
Hold the electrons, right? So there's only 3 parts in an atom, right? Okay. Protons, neutrons, and electrons. What's the neutron's purpose?
To
What do they do? It's almost nothing, but they do provide something.
Provides stability.
Mass. They provide mass to the atom. Okay. They provide mass to the atom. That's their function. Okay. It's the most noticeable function anyway. Protons are the positive things that hold in the what?
Electrons
The electrons, which do what?
hold together the protons.
No, they interact with everything around it. Okay? So atoms do what they do because of their electrons interacting with somebody else's electrons. Okay? They're either exchanging or sharing electrons with something else. Okay? And that's the basis for whatever anything is doing. Okay? The electrons are there and where they are because of how many protons they have, right? The protons plus the neutrons make that atom weigh whatever it weighs. Okay? So we're talking about numbers of protons. So what is the effective nuclear charge? Well, the nucleus is charged by the protons, right? Effective at doing what? Their job, which is holding electrons, right? So the more effective they are at holding them, the tighter they will be held, and that will make for a smaller atom. Yep.
So I'm just gonna just do something to make sure I got it. Okay. So basically for atomic radius, if it's going down Li and K, it'll be more of like the higher valence.
We're going to argue about energy levels. So anytime you've got two substances in the same group, then your argument should be based around their energy levels, specifically their valence energy levels. If you're arguing about two elements in the same period, it's about effective nuclear charge. Boron and fluorine's electrons are all in the same energy level, right? So there's no argument to be made there. So it's about effective nuclear charge.
Wait, so you're saying that all the AP, the high scores just going to be who makes the highest one? No
Yes.
matter how high it is.
No matter how high, you get put in 5 groups. Your name gets dropped into one of 5 buckets when they finish grading your test. The highest certain percentage go in the 5 bucket. The next group of people go in the number 4 bucket. The middle group of people go in the number 3 bucket. The bottom 2 go in the 2 bucket, and the bottom third or so of people go in the number 1 bucket. And that's how you get scored on AP exams. Yes.
Okay, so so for greater nuclear charge, could we?
Greater
just say
effective nuclear charge.
Greater effective nuclear charge.
It has to say that or it's not the same thing.
Okay, so like if I have boron and boron only has 1 electron in 2p, but fluorine has all those electrons in the other 2p.
Nobody has a proton in a 2p.
Well, electrons.
Okay. If you put proton in a 2p, they're gonna mark it all wrong.
Okay. But would it be like, so we can say it's like the one with less, that would be the larger one? I mean, I'm just asking just for like
Just
simplicity.
The fewer number of protons means a less effective nuclear charge. More protons means a greater effective nuclear charge. Less is less and more is more. Yep.
Get this in my head. So even though they're both they go up to 2p, B has fewer protons, but that doesn't necessarily mean anything. It's more about the effect.
Makes it larger
Okay.
because it has less protons. It has a less effective nuclear charge. Nuclear charge is less effective because it doesn't have as much of it.
Oh, that's true.
So could I
What?
put down?
This is where y'all's English class comes in. Y'all have to be able to understand the English language in words that are more than four letters long.
So could
That wasn't that hard.
Greater effective nuclear charge. Think about what it means. No, listen, you're not thinking, you're talking. Think about what it means. You're trying to come up with a question to ask instead of think about what it means. Think about what it means. Greater effective nuclear charge, and then read it backwards to yourself because we're English speaking people. And somewhere along the line, the English people jacked up the Romantic language and flipped everything around. Okay? So greater effective nuclear charge. The charge of the nucleus being effective is like what? Read it backwards. The charge of the nucleus being effective at what? It's greater at what? holding electrons, right?
See, that's what I'm trying to see.
Read it forward and then read it backwards. And think about it before you just start asking questions.
Okay.
Because you're too busy asking questions and not thinking about it
I thought
first.
about this, Harold. It'll just be so much quicker.
Right,
It's so much.
It's not, because you're never going to figure it out until you think about it.
I'm thinking, I thought about it.
You
Like,
got to
I'm ready.
process the meaning of the words.
Like, I'm ready. I'm ready.
All right, next question then. Here we go.
Wait.
Wait.
Wait a minute.
Let me finish for her.
Okay, so look, so you said that less equals less, right?
It does.
But technically in this, the less equals greater. Because the greater nuclear charge equals
Yeah,
less.
okay.
That's why I'm getting confused.
Every time I look at it.
Because like whenever you have B right here, B only has.
The more protons you have, okay, you're comparing it to the radius.
Yeah.
Okay,
that's
the
what
more
I'm saying.
protons you have, the more effective nuclear charge is. That's what I mean by greater equals greater,
Okay,
which results in a smaller radius.
okay.
Because it's not as big.
Cause and effect.
So, although they're both on the same energy level, B has fewer protons, which makes their greater effective nuclear charge.
No, it makes it less effective
Yeah, it
nuclear
makes it
charge.
less. It says
You
fluorine,
can't have a greater effective nuclear charge that's less.
well, less.
So nuclear charges, the effective nucleor charge is either less than or greater than
Okay.
the other guy.
All right.
Fluorine has a greater effective nuclear charge, which holds protons, which therefore holds in electrons. Which holds electrons.
Basically, the less there is.
How's the other side of the room doing? Y'all got this? They got it, all right?
Anyway.
Okay, I'm okay.
Pull in the more electrons.
Yeah.
The more protons. They're pulling in more electrons.
So the less, that's just.
Like, I know, like, I'm gonna.
No problem.
All right, next question, number 3. Fluorine smaller than iodine, okay? These share the same group, correct? So this is not about effective nuclear charge, all right? So this is about this is talking about energy levels, right? This is about energy levels,
The,
All right.
the iodine is in the fifth orbital.
not the 5th orbital.
Not the fifth orbital.
Energy levels. Energy levels.
They count it wrong if I said orbital.
There's no such thing as the 5th orbital. I don't know what that means. Doesn't mean anything.
I'm trying my best over here.
I know it.
The orbital.
No.
So then would it be okay if we put like fluorine is in the second energy level and
Fluorine's what? Not just fluorine. The atom is its own energy level. Fluorine's valence electrons. Okay. Everybody hear that right there? I hear that statement all the time. Something like fluorine is on the second energy level. No. Fluorine's valence electrons are on the second energy level. So what part of a fluorine atom has energy levels? The atom itself doesn't exist on energy levels. Its electrons exist on varying energy levels, okay? So the fluorine atom's valence electrons are on the second level. Iodine's valence electrons are on the 5th level, right? Or 5th, yeah. 5 is bigger than 2.
It's so weird because all of this big chemistry stuff just ends up to be as simple as 5 is bigger than 2.
Yeah.
That we're talking about really complicated things. It's just
Yeah, then it all simplifies down to 5 is bigger than 2.
So that's the simplest.
It's like a math problem.
Simple as it can be.
Yeah.
Okay.
Let's hold the big thing. Turns out to just be 27.
Well, the most complicated and misunderstood and not understood thing in all of science boils down to E equals mc squared. It's as simple as that, but it's infinitely complicated, and nobody completely understands it. But it all boils down to just E equals mc squared. That's all it is. But that's not all it is. So. All right, number 4. Cesium's larger than sodium for the same reasons we've been talking about. Okay. So again, if you're comparing two things in the same group, of which there are 18 groups, right? If you're comparing two things in the same group, it's the same argument. The details differ, right? So cesium is on the 5th or 6th energy level. Cesium repeating 5th, I think.
Yeah.
Okay, so its valence electrons are in the 5th energy level. Sodium's are on the 3rd energy level. So the details change, but the argument is the same. Just make sure you do not say anything about position on the periodic table. That is not going to get any credit.
I have a question.
Uh-huh.
So is there gonna be like any questions that are gonna like try to throw us off, like it's gonna say, something that's not true, for example?
No, they won't do that.
Okay, that's good.
Yeah, no trick questions. And they also won't give you, on these type questions, they're not going to give you diagonal elements. They're either going to be on the same group for the same period. They won't be diagonal, because at that point you got counter arguments and how you going to figure out which one wins. They'll ask you to do that. So, yep.
Is the hydrate stuff gonna be on the test?
Sure. Yep.
Will it be like the definitions?
No definitions on AP test.
What did she say? What did he say?
Ask about the hydrate lab we did, a little demonstration we did.
Well,
Yeah.
so you're saying that if it's in the same group, it's gonna be about the valence electrons of
The energy level of the valence
What
electron.
was the rule for if it's in the same?
Effective nuclear charge. Is it greater than or less than any other one?
Okay.
So nuclear charge is all the same, it's within the period?
All right, so if you're taking a time test, like our unit test, by the way, Thursday, will be over when the bell rings, no matter what. Okay, so let's go ahead and get that argument over with, right? If you're looking for shortcuts, that is equivalent to effective nuclear charge. Okay? Z with a subscripted EFF. Z, for whatever reason, is the symbol for atomic number, which is equal to the number of protons, right? So the effectiveness of the number of protons, ZEFF, ZEFF, some people call it, okay? You can write that, and that is acceptable to the AP folks as effective nuclear charge. If you just want to save a little space or try to be as quick as you can be.
So you would put greater Zeph.
Greater Zeph, lesser Zeph, whatever argument you're making. Okay. All right, number 5, krypton versus potassium. That's another effective nuclear charge argument. Okay. The better answer would be krypton's 18 protons. 18, no, it's 36, right? Krypton's 36, okay, and potassium is what, 19? Okay, so krypton's 18 protons have a greater effective nuclear charge than potassium's 19 protons.
Are you sure krypton doesn't have 36 protons?
Isn't that what I said, 36?
He said 18.
You said 18 again?
He said 18.
He said krypton's 18.
36 and 21,
You're out of table.
19, whatever it is, I don't know. All right, ionic radius.
What, my name?
No, because it's, AP, so everything's automatic. Sorry.
All right, so with ionic radius, you got two things that can happen to form an ion. What are they? Two things that can happen, not two words that mean the same thing. Two things that can happen. It can lose electrons or it can gain electrons, right? Can you lose or gain protons?
No.
Not in chemistry.
That would not be that open.
You can in physics, but not in chemistry. Okay? So in chemistry, when we talk about forming ions, we're always gaining or losing electrons. That's the two choices. If something loses electrons, it becomes positively charged, and we call that a what, Miss Grant? A cation, okay? When that happens, all right, it's losing outer energy levels. It's like peeling off an onion. Ever peeled an onion? You know what I mean by peeling? Onions are layered, right? Okay. You take the layers off of an onion. Same. I don't know. Maybe. I don't think I've ever watched it.
Yours is Shrek.
I think so.
He's like, we gotta watch Shrek.
What's
Yeah.
that?
Hey,
Hey, you never seen
Shrek.
it.
None of them. Not the first one, second one, third. He on an onion. And people are ogres. They're like onions because they have layers. He started peeling the onion.
So anyway, peeling an onion, okay? So for example here, nitrogen, nope, sorry, let's go to a positive, where's the positive one at? There's not one, that's good. Okay, anyway, so let's just say sodium and sodium 1+, right? Okay, so sodium has got 3 energy levels, like 3 layers of an onion. And when you take off its valence electron, it'd be equivalent to peeling off the outer layer of the onion. You now have a smaller onion, right? Okay. Now, here's where it gets tricky, so pay attention, okay? When you form an anion, okay? When you form an anion, you're adding electrons, but you're not adding energy levels, so it's not an energy level argument. When I throw more electrons into an atom, there is increased repulsion.
Wait, what? You said again?
Increased repulsion,
For adding electrons?
adding electrons. All right, so number 1 is an example of that. Why is nitrogen smaller than nitride in 3-? Okay, well, because when you throw those extra 3 electrons in there, there's an increase in repulsion. Basically, the atom swells up. Better way to say it is it expands due to that repulsion. It's kind of like blowing up a balloon a little bit, if you think of it like that.
Say that again.
Which part?
Number 1.
The whole one.
Expands to electron due to electron repulsion. Okay. Now, same true as for number 4 and number 3. Okay. What are they asking in number 2? Those are 2 different ions, right? Okay. Those are going to be isoelectronic. Okay. Those are going to be isoelectronic.
Wait, if they're isoelectronic, then how come one is bigger than the other?
Because they have different numbers of protons.
Yeah.
So now it's back to greater effective nuclear charge.
Oh, okay, that's it.
Okay.
So beryllium has 4 protons, lithium has 3 protons, right? Beryllium 2+ and lithium 1+ are isoelectronic. So their electrons are the same. That means if they're different, it's got to be due to something else. If they're different, it's because there's something about them that's structurally different, and that would be the number of protons. So now you're back to comparing 2 things on the same group, right? I'm sorry, same period. 2 things on the same period. So it's an effective nuclear charge argument.
And how would you word that?
I hope that went thunder.
Let it be.
It is.
I have, I figured out what I have. I have astrophobia.
Please, please.
It's bad. I actually have astrophobia.
Effective brain, effective nuclear charge for that one.
What's
It's
that
called
now?
astrophobia.
Like, how would you
What
word
would
that?
be the explanation?
This.
It's a severe
Like,
fear.
how would you word that for the isoelectronic, greater effective nuclear charge?
I would say that they're both isoelectronic, and that beryllium is smaller because of a greater effective nuclear charge of 4 protons versus lithium's 3 protons.
So then the effective nuclear charge, the greatest effective nuclear charge is going to go to the smallest one?
Makes it smaller. It's one with the most protons, which makes it the smaller atom. Yep. Okay. So if you have isoelectronic substances, okay, it's going to be about the effective nuclear charge because their protons are going to be different. They have to be. What, I have 6 minutes? Okay. Ionization energy. How difficult is it to remove an electron? The higher the energy means it's more difficult to remove it, okay? So the harder, the more stuck an electron is to the atom, the harder it is to remove it, the more energy is going to be required. So high IE means difficult to remove. So you got to put that number to something physical. Does that make sense? So we're given a number or a set of numbers. Some numbers are bigger than other numbers, right? What does that mean physically? In this case, it means that if somebody's ionization energy is 500 kilojoules per mole and another one is 700 kilojoules per mole, well, we all know that 700 is bigger than 500, right? What does that mean physically? It means that the electron that's got a 700 kilojoule per mole ionization energy is more difficult to remove than the one that has a 500. The higher energy means it's more difficult to remove. So we got to be able to put a physical characteristic to the number, or we're just staring at numbers. And we're just talking about this number's bigger than that number, and that's an observation and not an explanation. So we got to relate the number to the actual atomic structural difference. All finished. Excellent. Sure. Yeah. John, bet you never know this. It's close, isn't it? Devil might be in the details, but that's pretty close. All right, so
They should make AP chemistry 2 3.
they should. Most schools, that's what they do.
Really?
Yeah. Most successful schools. So the fact that we pull off passing scores around here with only one class period is,
So
I think, pretty unique.
So why is that? Why should they have it in this?
Why should
Yeah,
they?
what's your,
Because the class is too hard. It's too much to go over in one class period.
Okay, so what's your opinion on like blocks? Like we do certain
Oh, I
classes a
would
day.
wish to goodness that we had block schedule.
Really?
Yes.
all
All
the county
day
schools
long.
have it.
And any teacher who doesn't like block schedules,
I feel like
I'll go
you
on record
forget
and say that.
information faster. You got one class.
Huh?
You got
Why would you
seven
not
classes.
want?
Only 2 classes
Look, I know
at a
people
time?
that teach on block schedule, and you get an hour and a half planning period every day. First off, that's all it would take for me. That's the only thing you got to do to convince me, right? In the county right now, they've gone block schedule. They got all your extracurriculars are the last block of the day, so that means core teachers all have planning together at the same time every day. Genius idea. Okay, that means everybody gets to start ball practice at 1 o'clock. So that means kids don't stay up here till 7 o'clock at night practicing ball, cheerleading, whatever, band, all that stuff's on the field. At Alexandria, everybody's on the field at 1 o'clock, practicing band, football, volleyball. They're done. They're home. It's a win-win there. You get an hour and a half for classes like this. You set them up to have they call a modified block schedule where this meets every day all year long. So you get an hour and a half every day for the hard classes. Right. The only people that don't like it are the people that don't do anything anyway, and they complain because they got to have a kid in the room for an hour and a half instead of 45 minutes when they wasn't going to teach for 5 minutes anyway. What am I going to do? So they already wonder what they're going to do the other 40 minutes. Now it's what am I going to do the other hour and 20 minutes? Well, that's your problem, not mine, right? That's your problem, not mine. Like, I need time to teach people chemistry, for crying out loud, right? We're not up here memorizing when the War of 1812 started. We're trying to learn some chemistry. You know what I mean?
Yeah. First is like science and math.
Huh?
Like which classes would you want to go first? Like,
It wouldn't matter the order.
it wouldn't matter.
I do like the idea that and from what I understand about the county, they're putting all the extracurriculars in their last block. Because as a parent of a kid who's graduating, one that's now in, who plays ball, and be the same being in a band, it would be nice if they could get that done and come on to the house. Like, how much more sleep is a kid gonna get? They don't practice till 7 o'clock, right?
It would probably have like less homework.
Yeah.
Because like if you get all that done,
Or you can get it done at the beginning.
because you don't have so many classes to do homework. And like you split up the core class, there's less stress than
It's, I think it's a wonderful idea. It's more like college.
I heard
It's just,
Miss Davis was saying that one thing is like if you were to move to a block school, it's over like a semester or two.
not necessarily, but it depends.
Maybe
I didn't hear about, all I heard, like, Miss Wilson was telling me, like, she wanted to change the neighborhood where we could come in at 8, but like, they wouldn't let her, it's like something, like, they couldn't change.
Please push back school. I want to wake up at 6 o'clock in the morning.
I would rather,
Sticky
but
kids.
like,
I wouldn't, and then rather leave.
We tried to do it 7 or 8 years ago and it didn't fly.
Wow,
What is that?
The number one
She wanted
reason,
us
the
all
number
to
one
finish
reason
now.
is the principal at the time who was trying to do it, everybody hated him, including me, but I didn't dislike his idea, okay? I mean, I threatened to fight the guy in the parking lot one day, but I didn't, I still didn't think it was a bad idea, you know? Me and him had serious disagreements. Me and him had serious disagreements, but I don't throw the baby out with the bathwater. You ever heard that statement, right? Okay, so just because he was a jerk, he's actually in prison now. Just because he was a jerk, the principal was, yeah, the one that used to be here years ago. So, didn't mean that his block schedule idea was bad, right? But that was the first thing, is nobody wanted to listen to the idea because it was his idea. And that's a bad attitude. You only hurt yourself then when you throw out everybody's idea and start doing it first. But then secondly, some teachers just didn't like it. But I think maybe it was mostly they didn't like it because it was his idea. So it never had any chance to get off the ground.
Does it have to go through like the superintendent? the
Oh, yeah,
board?
they have to go all the way to the top, yeah.
Oh, so none of the people like this, like even the superintendent?
No, he was trying to get the superintendent's job, so they didn't like it.
Man, you.
Tanner, you stuck my head open wide.
He was a very crooked guy.
He's very questionable. Wait, you are?
You what?
He's very questionable. So what made you ever think of her?
Exactly.